Hi, this is Thomas. Welcome back. Our topic is differentiation, and we're going to look at two examples of parametric differentiation. We use parametric differentiation when x and y are given as functions of a third variable. The third variable is the parameter, and the two equations given with x and y as the subjects are the parametric equations. In this example, we read our requirement: find the gradient at the point P where t equals 2 on the curve given parametrically by x equals t to the power of 3 plus t and y equals t to the power of 2 plus 1. We'll follow the algorithm we have in the upper left corner of the screen. Step 1, find the derivative of y with respect to t. Our y equation, y equals t squared plus 1. The derivative of y with respect to t is 2t. Step 2, find the derivative of x with respect to t. Our x equation, x equals t to the power of 3 plus t, and the derivative of x with respect to t is 3t squared plus 1. Step 3 is the derivative of y with respect to x. And this equation is based on the chain rule. The process we'll use in step 3 is to divide the two derivatives we've calculated in step 1 and step 2. We'll divide derivative of y with respect to t by derivative of x with respect to t. In our example, the derivative of y with respect to t is 2t, and the derivative of x with respect to t is 3t squared plus 1. And this is our final derivative, the derivative of y with respect to x. Sometimes, as in this example, you'll be required to input a particular t value and then go on to calculate the gradient at that particular point on the curve. So, step 4, if required, as is the case here, calculate slope or gradient at given t value. Here, the given t value is 2, so when t equals 2, the derivative of y with respect to x is 2 times t becomes 2 times 2 over 3 times t squared is 3 times 2 squared plus 1, which simplifies to 2 times 2 is 4 over 3 times 2 squared is 4, 3 times 4 is 12, plus 1 is 13. So the gradient at point P, where t equals 2, is 4 over 13. We've completed our requirements, and this concludes example 1 of parametric differentiation.